Hi. So welcome to lesson 11. So today we're gonna end our chapter Trigonometry. Okay, so this is the last part of the try it for today and a few exercises. Okay, but before that, let's go to our previous lessons work. Okay, let's double check again your work. For your try it 18, please tick on your answer. A, B, I already discussed it with you. Okay, make sure your answers are the same as the one here, yeah? So, try it 19, part A, part B, part C, and part D. Okay, please tick that. And then your homework is question 3, 4, right? Okay, let's look at question 3, 4. Okay, so for those who don't know how to do this question 3 and 4, I already sent you the hint in a previous lesson. So for now, I'm gonna write down all the answers for you. Okay, so please compare your answer with mine. Okay, start from question number 3A. To find the length of AC, we use Pythagoras Theorem. Okay, you may skip this if you already have your answer, and you can double check your answer after. You can fast forward and check your answer. Okay, so AC using Pythagoras Theorem, and you will get 7.07 centimeter. Okay, please tick this part. And then for B, you need to find AG. AG also use Pythagoras Theorem. Okay, AG you use Pythagoras Theorem for this triangle here, AG. Okay, so you need to find this AG. You have 5 already, and you already found your AC just now, which is square root of 50. Okay, now square root of 50 here, the one that we haven't round off yet. Okay, so AG equals to square root of 50 square plus 5 square and then square root. And you get square root of 75, which is equals to 8.66 centimeter. Okay, please double check your answer. And then for part C, you need to find the angle of GAC. Okay, angle of GAC is here. Same triangle here. This is the angle that you need to find. Okay, you can use SOHCAHTOA, anything, because you have your opposite already, and you also have your hypotenuse, and you have your adjacent. Okay, for this triangle. So up to you what you want to use. Okay. Okay, for me here, I'm gonna use my tan. So tan GAC equals to 5 over square root 50. Then I inverse tan, 35.3 degree 1 decimal place. Okay, please tick the answer. Okay, so let's go to question 4. Okay, it's just a Pythagoras Theorem and SOHCAHTOA. So at this point, you need to know your SOHCAHTOA very well. Okay, okay. So 4A, we use the Pythagoras Theorem as previous lesson I already mentioned. So I think this one a lot of you get correct. So AC is 10 centimeter. Please double check your answer. And then for part B, CE also using Pythagoras Theorem, using this. So square root of 109, which is 3 6 feet, is 10.4 centimeter. Okay, check your answer. And then part C, AEC. Okay, AEC here is this triangle, AEC. The 90 degree is actually over here. Here. Okay, so angle is the one that you need to find here. Okay, so you have opposite, you have adjacent, which is your 3, you can use tan. So tan AEC equals to 10 over 3 73.3 degree. Okay, please check again. And then for the last part, part D, CEH we use K. Okay, this is the angle that we need to find. Okay, this one, CEH is this. And then this is a 90 degree. Okay, because we already have our EC, our length of EC just now. We already have the length of this EC, so this is my adjacent and this is my hypotenuse. Okay, so I'm gonna use cos. So cos CEH 8 over square root 109. Okay, CE is square root of 109 from here. Okay, I'm using the one with the square root, so I don't need to write down the decimal places so long. Then I inverse my cos, shift cos, so I get 3 significant figure is one decimal place is 40.0 degree. Okay, double check your work. This is your question 3 and 4 answer. Okay, I think this one you all be able to do. Let's look at question 5 again. Question 5A, B, and D. And C, I asked you to do it yourself. Okay, let's check the answer. So number 5C, using cos. I will use cos, VAN. Adjacent is your 17 and your hypotenuse 31. If you use saw and toa also okay, no problem. Okay, because you have all the length already. So here, after I round off to one decimal place is 56.7. Okay, double check and tick your answer. Okay. So let's go to the last part of the try it for this chapter. Yay! Okay, in the diagram, AB, BC, and AC are straight roads. Okay, this is a 3D. This is a 3D diagram. Okay, remember that. So, at the junction A, a vertical tower TA stands. Okay, so you must understand that this A, C, and B, they are on the ground. Okay, they are on the ground. You must be able to visualize this 3D problem. And this TA is a tiang. Okay, a tower. A vertical tower. Okay, so given that TA, okay, is already given there, is already mentioned. 37 ABC, 48 is all in the diagram already. And the angle of elevation of T from B. Okay, can you look at this? Angle of elevation of T from B. So you look at this, B is on the ground, right? So A is also on the ground. Okay, that is why your angle of TAC is 90 degree. It's already on the diagram here mentioning that it's 90 degree. And then this B is looking up to the tower T. Okay, it's going look up to the tiang atas the T. Okay, so it forms a angle of elevation because it's upwards angle. Okay. Okay, so next find the distance of AB. So you need to find the distance of AB. AB mana? Here. Okay, so we're gonna use this triangle here. Okay, the blue triangle that I draw here, right? Okay, it is a 90 degree. Okay, I'm gonna draw a triangle here. It's a 90 degree. Your T here, your A here, and your B is here. And it's a 34 degree. And here is 37. Basically, this one I draw it out to show you the side view is like this. If you are looking the view from this way. Okay, so now we're gonna find AB. Okay, so this is the one that we're gonna find. So how are we gonna do this? We use sokatwa lah, sokatwa. So you have opposite already, and this one is your adjacent, so we use tan. AB. So AB is 37 divided by tan 34. So AB is 54.8548. Round off to 1 decimal, 3 significant figure because this is distance, so it's 54.9 meter. Okay, that's the answer. Okay, how about B? The shortest distance. Okay, you see the word shortest distance. Shortest distance definitely tells you a 90 degree, okay, right angle, perpendicular. From A to BC. A is here and BC is this line, so it forms a 90 degree like that. Okay, so this is the one that they ask you to find. Okay, I put an X here, or the X, the distance that you need to find. Okay, so how are we going to find this distance? Huh? Okay, we already find our AB just now. AB just now was 54.8548. I'm going to zoom here. Okay, this length we already have. So we have opposite. This is our hypotenuse because this is 90 degree, right? So we can use saw. Okay, so we can use saw from there. So sine 48 equals to x over 54.8548. So x is okay, so you get a 40.765, round off 3 sig fig is 40.8 meter. Please press calculator and double check for me. Who knows, I got careless mistake leh. Okay, let's look at C. So the greatest angle of depression. Okay, angle of depression here is a looking downwards one. Okay, downwards angle from horizontal. Okay, from T. So from T, here is your T to a point on the road BC. Okay, to the road of BC. So look at this. If my T here, I'm looking down, means that I have a horizontal level. You're looking down. Okay, which way will gives you a greatest? Okay, so here, this shortest distance. Okay, shortest distance here. If we are looking downwards like that, okay, because this is a 3D, this is a 3D. So if we are looking downwards like that, here will gives us the greatest angle of depression because you are looking down from here, the shortest distance, then only you will get a greater number. Okay, let me explain this to you. Okay, let's say if this is T, this is your tiang A. If you are looking downwards, okay, this is your eye view. This is your eye view. You are looking, my eyes looking here, right? Okay. If my eyes is looking here, and it will form an angle of depression if I look down like this, isn't it? Look down. This is my angle of depression. Okay. But then, if you're looking further away here. Okay, I think I explained to you in the previous lessons, but then if you don't remember, it's okay. If I'm gonna move the yard, let's say this yard is going all the way front here, this angle is different. Okay, you try to compare the angle if I put it over here, 15.9 degree, the angle of depression of the yard from that niche, okay, is 15.9 degree, is further away, right? If it's getting nearer and nearer to that niche, the angle is become larger, right? If it's further away, then the angle becomes smaller and smaller and smaller. I'll explain to you again. If you're looking further away, right, you're looking this way, the yellow line, if you're looking here, the flower, let's say, then the angle of depression here will be less than the angle of depression just now, the pink line, isn't it? Then if you are looking here again, the green line, the angle of depression, you're looking downwards like that, right? It will be more, okay? It will be greater, even greater, right? Meaning to say that the shortest distance that form from this tiang, okay, if it's further away, the further away it is, the angle of depression will be smaller. Okay, you need a shorter distance. So the only shorter distance from the A, you look at this A. Since we already find it in part B, shortest distance is here. Okay, this is your shortest distance. This is not shorter distance. This is even longer than the distance of forming the 90 degree. Okay, so meaning to say that your angle of depression will become greater if you're looking down to here. Okay, so this is a 90 degree. Okay, this is your Tiang TA 37. This is your shortest distance just now, which is your X. Okay, your shortest distance of X, which is this one. Okay, 40.765. Okay, your shortest distance. So your angle of depression is here. You're looking downwards to here. This is your angle of depression. So to find this angle of depression, okay, you look at this. This is a 90 degree, right? And then it form a alternate angle here, which is also the same angle as your angle of depression. So here is also your angle, same angle. Okay, so to find that, you have, this is a 90 degree, this is the opposite, this is your adjacent, so you can use SOHCAHTOA. Okay, so I use tan angle equals to 37 over 40.765. So your angle of the depression will be equals to 42.228, which is 42.2 degree in one decimal place. Okay, so that is the answer for try 20. Okay, so today we want to cover exercise 1.6. This is exercise 1.6. Exercise 1.6. This is page 44. Question number 8. Okay, 9 and 10. Okay, we're gonna cover all that 8, 9, 10 today. Right? Okay, so question 8. Okay, question 8. Let's look at question 8. You can try to do by your own first. You can pause the video and try to do by yourself first, and then you compare with my answer. Okay, you try. You try first. In the diagram, A, B, C, D, E, F, G, H is a cuboid and M is the midpoint of AB. Okay, AB is 6, is already in the diagram. BC is 5 in the diagram. CG is 4, is in the diagram. Find the length of AC. Okay, so AC here is this one. Okay, so if we want to find this AC here, okay, here is 6, here is 6, so meaning to say that here is 3 and 3 because M is the midpoint, okay, of AB. Okay, if we want to find AC, okay, this is a 6 and this is a 5, it forms a 90 degree there, like that. It's a 90 degree triangle. A, C, and B. So this is your 6, this is your 5, and we can use Pythagoras Theorem to find our AC. AC equals to square root of 6 squared plus 5 squared. So it's square root of 61. Okay, in round off to 3 significant figure. I want you to do it by yourself. Okay, do it by yourself there. And then part B. Okay, the length of MG. So MG here is this one. Okay, so to find this MG, you look at this MG, we need to find, okay, there is a 90 degree here, you see. It's a 90 degree. So if I were to draw the line, it will be, to draw the triangle, it will be like this. Okay, this is your GCM. Okay, if you want to find MG, here is 4. Okay, we don't have angle, we don't have any other length. But this length we can find. So we find MC first, then only find MG. Okay? So we find MC dulu. So MC is square root of, you see this MC? There's another triangle here, MC. This is 3 and 5. So we use the Pythagoras Theorem, okay? It forms another triangle there. Which gives you a 5, 3, and this is the one that you need to find. This is your MC. So we need to find our MC first. So meaning to say that we are doing Pythagoras Theorem 2 times, okay? 3 square plus 5 square, square root of 34. Okay, I'll leave it because I don't need to round off to 3 sig fig. I'll just leave it. MC is square root of 34. So here is my square root of 34. Then we can find our MG using this triangle. So this triangle to find MC, this triangle to find MG. So MG equals to square of that plus square of 4. So round off to 3 significant figure. Okay, you do it by yourself. For this, do it. Find it your own. Okay. And then let's look at C. C is finding angle CMG. CMG. Okay, let's look at what is CMG over here. CMG is this angle which is in this triangle already. So we're gonna find this angle. We have opposite, adjacent, hypotenuse, SOHCAHTOA, up to you want to use whatever lah. Okay, but I use tan lah because I have opposite and adjacent. I use tan. So GMC or CMG is the same. Angle CMG, tan opposite over adjacent. You see, we do a lot of SOHCAHTOA here. I hope you already master your SOHCAHTOA. So 3 sig fig is 34.4 degree. Okay, that's my answer for part C. Now let's look at part D. HMG. Okay, let's look at HMG. You see this? This is a triangle, and they are asking you to find this angle over here. Since this is a midpoint, okay, meaning to say that from H until this midpoint and the G until this midpoint, they are the same. Okay, they are the same length. So if I were to draw a triangle that view from top, it will be like this. H, G, same. And then this is my M. I'm finding this angle over here. Okay, HG is already 6. MG we also already have. This is my square root of 50. My MG is square root of 50 from here. Okay, square root of 50 there. So here is also square root of 50. Okay, so you can use SOHCAHTOA. If you want to use SOHCAHTOA also can. You divide this into half. If not, you can use cosine rule. Okay, you can use cosine rule to find. Okay, since we learned cosine rule already, let's use cosine rule to find the answer. Okay, so I'm using cosine rule to find this angle here. So 6 square equals to square root of 50 square plus square root of 50 square minus 2 times cos HMG. HMG. Okay, remember this one and this one must be opposite to each other. Okay, so I'm gonna continue this. So this one when you times is 50 cos. Okay, or after I times all this, I press calculator, I get 100, or you can straight away write down 100 also can. Okay, that means I'm moving this whole thing to the other side. Okay, and then this one will left, this one square root 50, and then you square become 50, yeah? And this one also the same, it will become 50. You can try press the calculator for that. Then minus 6 square is 36. Okay, and then I move it to the other side, this 100. Actually, you can press whole thing in your calculator already, huh? So shift cos this whole thing in your calculator, it will become 50.21. So round off one decimal place is 50.2 degree. Okay, I think your cosine rule, this part you can do it by your own. You check and see if your answer is this or not. Not necessary for you to copy everything from me. Okay, so that's for question number 8. Okay, so let's look at number 9. Okay, number 9 here. So A, B, C, this is a different shape of 3D. Okay, ABC is an equilateral. This is a type of pyramid also. Okay, a triangular type of pyramid. And you look at this, ABC is equilateral, meaning to say that this is 20. Since this is 20, this is also 20. This is also, BC is also 20, but since M is your midpoint, so here is 10 and here is 10. Okay, so VA is a vertical stick. Okay, this is a tiang, it's a tiang on the ground. This is on the ground. ABC is on the ground. Okay, so find the length of MA. MA is this one. Okay, so here is definitely 90 degree. Okay, because it divides into 2, 10 and 10 since it's an equilateral triangle. So this is a 90 degree. To find this pink line, we use Pythagoras Theorem. So MA equals to square root of, so it's a square root of 300 and then 3 sig fig. You find it by your own. Okay, because I'm gonna use the square root of 300 for later. Okay, the one that is rounded off. You cannot leave your answer, by the way, especially science students, you cannot leave your answer inserts for DMaths, unless if the question say exact. Okay, if A-maths you can, but D-maths you cannot. You must leave in 3 significant figure. Okay, so part B, the length of VB. VB is this over here. It form a 90 degree also here. This is a 90 degree. So to find this VB is also a Pythagoras Theorem. Okay, so part B, VB, we also use Pythagoras Theorem using 21 and 20. So this one I tell you is a square root of 841. So the answer is a whole number, which is 29 centimeter. Okay, so here is 29 centimeter. And next question, the length of VM. Mana VM? VM is this. Look at this. This is also a 90 degree. Okay, view from here is 90 degree. Okay, 90 degree. So we are finding this length of the VM, and we know this length already. Okay, this is MA. MA is this square root of 300. So it forms a 90 degree like that triangle, where this is your VM and A. This is 21 and MA is square root of 300. Okay, I draw the triangle here already. So we can use Pythagoras Theorem for VM. Everything Pythagoras kan. For now lah, this one is square root of 741. So you round off and write down the answer. Okay, and then part D, that's for your VM. So part D, we are finding angle of ABV. ABV, so we will use this triangle. So this one use adjacent, opposite, sorry. You want to use opposite, adjacent, since we have 20 here, or since we have 29, you want to use hypotenuse, you want to use SOHCAHTOA, anything lah. You do by your own for D. Okay, you do by your own for D, DIY. Okay. E, angle of AMV. Angle of AMV is here. Another triangle. AMV, okay, AMV is here already in part C. Okay, I already draw it out for you. So this is the angle that you need to find. Okay, you can use SOHCAHTOA also. This one I leave it for you to do, SOHCAHTOA. You must master your SOHCAHTOA. Okay, this one you do it by yourself. Okay, so that's for question number 9. Let's look at question number 10, the last one. Okay, the last one for today. So this is also a triangular prism. Okay, it's a triangular prism. And BCE is 90 degree. Okay, it's all in the diagram already. Now find the length of CE. Okay, I'm here to guide you only. I want you to do it by your own. So CE, you look at this triangle. This is a 90 degree triangle. You need to find here. Also use SOHCAHTOA. Okay, I'm gonna draw it out the triangle for you from the view. BCE. You need to find this. You have 18, you have 30 degree. Okay, so you use SOHCAHTOA, you find it yourself. Okay, do it yourself. Do it yourself. Okay, B. Find the length of BE. BE is here. So if you already found your CE, you can find your BE already. So this one you can use Pythagoras Theorem to find the answer. Okay, also do it yourself. Now part C, the length of AE. Okay, AE, there's another triangle here, you see. AE, we use this triangle. Okay, so how we do this question? Okay, we have can we use this triangle? Think again. We only have CE. AC we don't have. AE we don't have. Angle is only 41. So we don't use this triangle. Okay, do not use this triangle. Okay, I'm gonna hint you here which triangle we're gonna use. Okay, you look at the triangle of this. Okay, so this will form a 90 degree because you're looking from the top. Because we are given 41, so we're gonna use that triangle. Okay, now hint you here. This is the right angle triangle with ABE. This is your 41 degree. Okay, BE here we get it from part B. Okay, you do it from part B. The answer here, you bring it down. Okay, you bring it down for your BE, then you can find your AE here because this is your hypotenuse, this is your adjacent. You can use K to find your AE, right? So next is part D. Okay, part D, to find the angle of CAE. CAE, then we can use this triangle just now. This is the 90 degree. This is the angle that you need to find. So now, AE, you will find it from part C, and then CE you already have in your part A. Then you can find this angle over here. Okay, this angle over here you can use saw. Okay, use saw to find sine. Okay, the triangle is like this. This is the angle CAE. This CE you find already in part A, and then this angle of this length of AE you find it in part C already. So you can use opposite and hypotenuse, so you use saw to find the angle. Okay, so you do it by your own. Alright, so today's lesson is lesson 11. Okay, you can try it 20, question number 8, question number 9, and question number 10. Okay, so that's all from me today. Bye.